All right, let's go through this one now. You'll be asked to find the value of x over here. Now, if I had to, for example, let's say, draw a dotted line through here, okay, and create two triangles on either side, what you'll notice is because C is the center of the circle, this would be a radius, this would be a radius, and this would be a radius. And I'll end up with this isosceles triangle. And I can say this maybe is part of the proof, isosceles triangle over there. So that means this angle will be equal to that half there. This angle will equal to that half over there, right? From the radius. And I know that this angle over here is 40 degrees, all right? I also know that if I had to extend this line all the way through, let's just say all the way through, then let's suppose I made this dots y. So I made this y, made that y, and I made that y, and I made that y, right? Or let's make these different letters. Let's make this one y, let's make this one a, this one a. So those are the angles. Angle A, y, and y. From this triangle over here, I can see that this angle is the exterior angle of that triangle. And we know that the exterior angle of a triangle is equal to the sum of the opposite interior, which means this is going to be y plus y, which is 2y. And on this side over here, this triangle, I've got a plus a gets me 2a, also exterior angle of the triangle, of both triangles. So if I'm at the center over here, C, right, I'm going to have 2y plus 2a, which is equal to 40 degrees, right? If I take out 2 from there as a factor, then surely this has to be 20 degrees, right? Because 2 times 20 equals 40 degrees. So therefore, y plus a must equal 20 degrees. And where is y plus a? Y plus a is there at the top. So therefore, x is equal to 20 degrees. And this is the proof of angle at the center is equal to 2 times the angle at the circumference. If you're asked to prove it, then you would basically use that as a methodology behind it. The concept of bringing in step 1, if you have to remember this, what did I do? You got to construct the line BC through C, you could say B through C. That's the vertical line, dotted line down. Creating two triangles, and then also look at radii, which are equal, and isosceles triangles. And once you see the isosceles triangles and you see the radii being equal, you then look at the exterior angles of the triangle. And then lastly, you just use a calculation like this to prove a little bit of algebra factorization, factorizing the two and solving for y plus a, which is x. Okay. If you had to just write down the statement, you would just say x equals 20 degrees, and the reason is angle at the center is equal to 2 times the angle at the circumference. And this is if you specifically ask for the angle and the reason that x is going to be equal to 20 degrees. The proof, however, has a few steps in it, and that's proving the angle, proving this reason. That's what we're doing over here. This is the proof of the reason. Now the question did ask to find x giving reasons, which means that this would be the method, but I've just added the proof in there.